Yeah, hello. My name is Afan Kodani, CEO and founder of Cloud Inspire based a company based in France. And I'm about to introduce you, and we are going to take advantage of cloud solution or clouds in Africa. So I want to make sure that, okay, this presentation is not yet ready. So I need your contribution. So for me to, to build something together. So I might request from you some answer, some question, or I will also take some input from you. That's right. So my background is I'm a network engineer, uh, like for training, and I've been working for like a system and engineer, system and network engineer for AFRINIC for 4 years before moving to France, working for Red Hat, like a senior solution for Red Hat France. And now I've built my own company, promoting a software called Atohoun, providing a solution cloud as a service. So I'm going to share with you what is it, what the cloud is it really about, how we can take advantage of it, and how we in Africa can do something slightly different. So the agenda will be simple. What is cloud? We see the different type of cloud, the services the cloud is providing, and also how do we are going to build a cloud, the concept, and also how are we going to build a cloud in Africa region. So if I want to ask you, what is the cloud? What is it really about? Can someone can answer? What's the cloud? We all heard about cloud everywhere. No one? Okay. Who wants to try? At least. Okay, cloud is quite simple. It is only an abstraction layer of resources that can scale and across a network. Uh, Cloud is usually used to enable cloud computing. And we cannot say that cloud and cloud computing are technology by themselves. To be clear, cloud is only an environment where we can run an application. It is only an environment. So when we're talking about cloud computing, is the act of running a workload in a cloud. And then we have now the technology called the toolings are the things that can help you to build your environment. When you are talking about hardware, we are talking about software. So it's quite simple, isn't it? So what you have to keep, cloud is an environment, cloud computing is an act, and then we have the tooling, the software, the hardware, no matter what, we don't care. We have different type of clouds. We have the public cloud, we have the private cloud, we have the hybrid cloud, and we have also the multi-cloud. For now, because things are changing so fast, for now we have only 4. But we don't know, maybe in 2 or 3 years, another type of cloud can come out. So when you are talking about public cloud, it is only a way to create a resource. The resources that are created for you to use are not owned by you, end user. It's owned by someone else, the public provider. He is giving you a resources for you to run your network, run your storage, run your application, run whatever you want. But he's the one managing the tooling. Let's call it the tooling, the hardware, the software, all those. He's the one managing it, and you can run only the application on top of it. You have now the private cloud. The private cloud, we can say it roughly, is when you own almost everything on the cloud system that you are providing. So you are responsible of the hardware, of the software, of the power, electricity, and about the the processes, the management, and all those. We have now the hybrid cloud, where you have a mix in between the public one and the private one, and you share the load across those two. So you can have a part of your network on your local machine on-prem, and have a part of your network also on public. And you share the load in between the two, and you can keep a part of that secure data in-house and put some, how do you call it, data on the public cloud. And then comes in another type of cloud where we call multi-cloud, where you have a combination of a private and a public, but not directly linked in between them, themselves. So you can have many, how do you call it, system not connected, but you are the one managing all those systems. So you have the multi-cloud. So in cloud, we have services. The services that we have in cloud are what? Infrastructure as a service, where you they compute like the resources, the storage, the network are provided through the end user by network connectivity. So you have the infrastructure services, like a service that we can have example of Dropbox, or there are many of them. You have now a platform as a service where you have only the platform, the application that is sent to the end user, and he don't need to care about what are the hardware behind or application behind. He just needs a service, and the service is provided to the end user. We are talking about the platform as a service. And now comes in this software as a service. So it's like the entire software is handed to the end user. It's like the material, the hardware, the software, the application is handed to the end user. So he run an application end to end without having to manage the life cycle of the application he is running. You have an example like Google application, or let's call it again Microsoft application, all those that we have the cloud solution service provided to you. And people can push it to the edge and say that we can have down everything as a service, isn't it? Can we have everything as a service where we provide anything you want, just name it, just provide it to the end user? Yes or no? Because we can have an infrastructure as a service. You can run your own network. You can run your your storage. You can run your hardware like a service. I can run only an application like a service. I can run also a software like a service, the entire software like a service. But I just want to say everything as a service. Is it possible or not? Yes, it is possible. Just name it. Everything as a service. It is doable. You just name your service and you put your service as a service. So what does it mean? Does it mean that we have all those trendy words saying that everything as a service is like having an application hosted in a system, and that's it? So I share with you my network, and that's it? Can we talk about the cloud if that's the case? So if that's the case, there's nothing new. So it's only about, we are talking only about hosted services, isn't it? No, it's not really about that. Doing cloud is even more than only hosting a service and just hand it to the end user. It's more about a paradigm shift of how we see the network, the infrastructure, IT. It is mostly about how we manage and we rule the network behind. So the first step is strengthen the continuous and the delivery process. We just need to strengthen it. So we have the plan, we have to plan it. We design, we code, we build, we test, we release, We deploy, we operate, and we monitor. And then when we are happy, we celebrate. And then we repeat. Why is it important to celebrate? No. It's important. Yeah. Please, can you
Oh, so you can enjoy the moment before you break something else again.
Exactly. So it's like when we are putting automation in the process, in the core process of the chain of what you are doing, it's important to have the human bonding actually. So you cannot do the cloud solution or the cloud computing or a complete automation without having, this human interaction. So the human is still in the middle of the decision. So you cannot do it on your side without having the interconnection with the other person of your team. It's also a culture of bonding people while you are doing something completely automated or fully automated. So it's important for you to celebrate before breaking again, and then you restart. You design, you plan, you design, you code, you build, you test, you deploy, you monitor, and so on and so forth. You break down a complex system in small pieces of application that are very autonomous. Why is it important to break down a complex system in small application, very autonomous? Why? Why don't we build something completely big and we say this is our system? We are talking now about microservices. Why is it important to have this term of microservices? To have a better, how do you call it, management of the life cycle of each product, of each application we are running. So it's easier to upgrade only an application that runs by his own than make the upgrade of the entire system. So to move from, let's say, for a version of 1.1 of Apache to something else, it's better to do it in the small piece than running an upgrade for the entire system. So you can manage your rolling update easily. So it's important to break down your big system in small pieces, what we call microservices, and then you can manage the whole system together by providing what we call an API, that is the application programming interface. People are talking about API for ages, so there's nothing new actually in what you are saying. There's nothing new. The cloud computing is only bringing a way to the process that we are using before in the new age. That's it. Nothing has changed. It's only strengthened the process we are used to use before. So APIs are not new in this world, isn't it? We are talking about APIs for ages, but now APIs are quite critical in cloud computing. It's like people are saying cloud computing is API nation. They might be right. It's like now it is API everywhere. And then those API need to be well documented. Why the API are and need to be well documented? Why? To interconnect to, other application. So if it is well documented, the others equipment can just look at the documentation and interact with your application without having to ask you about what. Now the interoperability of the tooling or the system we are using are via API. And we need to automate all the process along the way by tooling. And we need to, I say it, forbid the human intervention during the life cycle of the product. So once the code is released, we don't need human to start updating the code in between the product life cycle. So once the code is released or the application is released, from the testing to the staging, to the production phase will be automatically straightforward. No human intervention in between the process. Why? Just to avoid human error or action or situation we are not aware of. So the same way you deploy on staging or on testing, the same way you deploy on staging, the same way you deploy on production. So if something breaks in staging, there's no need for you to deploy in production because it will break. Easy, isn't it? And then we need to avoid also some repeating those tasks we used to do, like a system engineer, like checking, doing the job. Someone raise his hand, say, okay, can I have a virtual machine? Yes, create a virtual machine for you. Can I have an additional disk? Yes, create a disk for you. So if the system engineer are spending their time providing those services, how time they will have for themselves to do something else? So the idea is to handle all those tasks to the end user so the end user can do it by himself. And then as system engineer, you can focus on something else, more productive, more interesting. So you are getting time by handle to the end user via a self-service portal, whatever he wants to do on your system without having to go and do it by yourself. Because what is the added value for you as a system engineer to just create a virtual machine every day? Me personally, I don't see any. I don't see any. I can create it once, I can create it twice, but asking me every day, it's just overkilling, right? Then building a cloud is only about methodology that put emphasis on processes. This is, I want to strengthen, it's about processes. The processes are very important. So you cannot go for automation when you don't have a strong process. Automation requires strong processes. Then we talk about, agility and DevOps culture. We need to automate all the tasks about, we do some iteration and do the testing before deployment. Automate the provisioning and do the testing very quickly. Providing, API, self-service portal, do some what we call telemetry and chargeback to be able to see actually to see the costs of your network or the system that you are providing, how much is it costing for you and how much you can charge the end user who is using your network or who is using your resources that you are handed to him. So you put a kind of telemetry for you to know exactly what is the load of what he is doing on your network, for you to start planning how you can grow if there's need, or if you can scale down if it's not really used. Good? So there's no single and perfect cloud architecture or infrastructure. There's no perfect one. So that's why I say I might need your help to, if you want to build something, I might need your help to, I need also your input to start building something, unique. So all the cloud requires like a software, like operating system, like Linux or Windows. And then on top of it, we have application that will do the containerization, the virtualization, or can be only bare metals. And then you have also the software that will run, all those tooling for you to automate the process along the way. So we define cloud by what they are, by what they do, rather than what they are made of. So no one will say my cloud is VMware. No, my cloud can help you to create machine in 3 seconds or in 4 seconds, and you can migrate your machine from another data center to another one. Let's say we use AWS, right? Most of us, we use AWS. But who really care about what is the hypervisor technology behind the machine Amazon is providing? Who really care? No one's care. Really, isn't it? We don't really care. We only need the machine, and that's it. But who ever think about, okay, Amazon is using Zen, now he moved from KVM, and no one's care about the technology behind. We only care about what are the services the provider is giving. Is it reliable? Yes, that's it. Is it fast? Yes, that's it. What are the technology behind? We don't know, and we don't want to know. So in Africa, how can we take advantage of all those way of thinking, of all those new trendy world, all those new age, let's call it that way, new age? Why do we all move to the cloud? Why we all move to the cloud? Can someone want to try why we need to go to to cloud? Who wants to try? Why are you asking me to go to cloud? What? For speed.
It's also cost effective.
For cost effective.
Yes.
He's talking about speed. He's talking about cost effective. Someone else? For NAT. For NAT. Avoiding NAT or to promoting NAT. Please? I need to.
Storage infrastructure.
What? Storage infrastructure. Okay. Virtualization. Mutualization. Uptime. 100%. There's okay. Actually, we cannot reach 100%, but okay. I got your point. Yeah, you. With IPv6, we don't need cloud. Oh, this is another topic. With IPv6, we don't need cloud. Cloud is bad.
Because in devices,
Yeah. 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 Okay. Now he got. I think he says something very interesting, and some make a lot of confusion, actually. So when I say about cloud, most of you has made also this error. When I take it, why do we go to cloud? I'm not saying why are we going to public cloud. I'm not saying that. Why are we going to do something like hybrid or private cloud? Not going to the public cloud. I'm not say move your data to Amazon, Azure, or Google, and then you can go and sleep peacefully. I didn't say that. So when I'm talking about cloud, I'm talking about the mindset, the methodology behind. So you can have machine on your own data center and have a proper way to rule it and manage it and have the same flexibility that you're having on Amazon or Azure or AWS, or even on Oracle, cloud, who is coming up now. It's only about the processes and the way you manage your network. So it's not something complicated. It's not. It's only about strengthening the processes that you are using to manage your network. You strengthen your process, and that's it. Even if you have, let's say, you want to deploy even V6 or all those applications, it's better to do it in the cloud way. So you have a better way for you to manage the changes and then revert back if something breaks. So when I was saying go to cloud, I'm talking about you doing your own cloud, something unique to you. So you define your network and you apply it to the different cloud providers, not the cloud provider that after that define your own network. It is a way to change the paradigm. Good. So going to cloud will help you to have an accurate documentation, because it is the documentation that will help you to provision your network, and it will be only that way, not your network that will do your documentation. No, you document and then you provision your network or your infrastructure. So for sure you have an accurate documentation, because you strengthen the process. You document first and then you deploy. If something goes wrong, you revert back, because you have a well-known working version. The process has strengthened. You automate all the process along the way. No human interaction. It's like when you start, the system can start from the staging or from the testing to the production without you having to do the manual job. You reduce human errors, because we all know that I cannot say 100%, but almost a lot of percentage of how do you call it, outages are coming from human errors. Someone want to do a changes, and the changes and this change is not well mastered, and we have what we call an outage. Just to reduce it, it's better to have a complete automated and well-documented version, so you can revert back to the well-known working version if something goes back wrong. You can go live stress-free. How many of you, before going to live, starting praying, say that, okay, we are hoping nothing will go back? Because if you have everything well documented, you can go live even during the weekend, because you know that everything are under control. You are able also to reproduce your entire system again and again and again, because everything is well documented. Through the tooling that we are having now, like containers, you can replicate your entire network, your entire system on the containers, and have the same behavior if on those micro environments. You can standardize the process for you to deploy from testing, qualification, and then production. Everything like this will be standardized. So the same way you deploy on staging, on testing, the same way you deploy on staging, the same way you deploy on production, the same way. So you can see the error beforehand. You reduce time for live system troubleshooting, because now it is easier to trash and rebuild than trying to troubleshoot, isn't it? If you master your system, it's better to trash and rebuild and respond than trying to see what went wrong, if what is what. Did someone touch the system? Yes, when, why? You don't ask those questions anymore, because no human interaction, even on the live system. If something goes wrong, you trash the system and you respawn it. It will save you more time than trying to troubleshoot it. And then we, as sys engineer, we have more time to enjoy life, to think about added value, solution that can improve our life or can improve the end user life or work. So we are all winning in this system. So having a cloud solution is having only an IT system that follow the clouds, this philosophy of cloud system that can be addressed by other computer through a network, that contain a repository that help another system to fetch information and have an accurate version of tooling that are deployed, along the way, and that can be provisioned and scaled via automation as quick as possible. Now here, it's the listing of tooling that we can have that can help you to, is it here? Yeah, to build your own cloud system. We have for containers, you have Kubernetes, you have Red Hat OpenShift or OKD, you have Docker, you have Rancher, you have CoreOS, you have Apache, you have Mesos or Marathon. For cloud infrastructure, you can use OpenStack. You have automation tool like Ansible, Chef, Puppet, monitoring, Web Prometheus, cAdvisor, Elasticsearch, Logstash, and Kibana. For the storage, cloud storage system, you have Ceph, you have GlosterFS. For virtualization, you have Proxmox, you have Red Hat Interface Virtualization, you have OVIrt. You can have also KVM or LibVirt. You have code versioning. Those tools are quite mandatory in the cloud solution, the versioning part, because everything will come from the versioning part of your system, because everything will be like code. Every infrastructure will be like a code. Everything will be like code. So it's important for you to have a versioning of the code that you are deploying. And then you can use the continuous integration testing, like a GitLab runner, CircleCI, Jenkins, or have a repository like Artifactory or Nessus. Do you have questions? Do you have questions? Everything is clear?
Thank you very much, Daniel, for that great presentation.